Hey everyone, welcome back to developmental biology. Today we're going to be working or learning about the Somites. So leading up to this point, we've talked about them a lot, right? Well, we haven't really talked about them a lot. We've mentioned them a lot, like the area next to the neural tube and the notochord there that run kind of parallel along that. Again, AI image of nonsense, but it's provocative, right? So like when I was first making my lectures, not to get too tangential here, when I first started making my lectures for bioinformatics and things like that, I wanted to get engagement online, right? Because I want to create this resource as part of Praxis's mission at the time to like provide educational resources for other like places where you don't have a lab. You can still do biology with bioinformatics if you don't have a lab, etc. Anyways, I was looking up ways to like garnish engagement, and one of the things was like, oh, have flashy thumbnails, right? And so that's why you see streamers, like every streamer you follow on YouTube or whatever, like it's like catchy headline, and it's all the same trope, right? It's like catchy headline, you'll never believe this, and it's a streamer going, or like they've got to feel so stupid making those faces like over and over for every thumbnail, like, oh, covered it, like. Anyways, these are catchy thumbnails, I think, even though they're nonsense, but I don't even post them on YouTube anyways. You know me, I'm tangential, but like next time you look at those thumbnails, just think how stupid they have to feel making those faces over and over for every video they put out. It's kind of ridiculous. All right, let's go. Somites. I say that and then watch in, a year from now, you'll see all my videos have the same reactions. I'll be like, sell out. All right, so here's just kind of an image of this developing, I think this is a snake. I don't have it in my notes for some reason. Sorry, I'm getting my pointer out. So we're going to talk about some of these other things that develop. We spent a lot of time on the nervous systems so far because that's very important. The brain, the spinal cord, the neural tube, how it's influenced by the notochord, yada yada yada, peripheral nerves, etc. Now let's look at the other stuff, right? So more of bone, muscle, internal organs. So we're going to move in that direction. So you can see kind of on this image, you see some of these vertebrae of this, like I said, I think snake, but maybe a fish, probably a snake. Anyways, let's go. All right, so the Somites. So this is what I was talking to about how we haven't really talked about it, but we've mentioned them a lot, right? And so we have these tissue areas next to the neural tube and the notochord that will drive or develop into other parts of the body, right? So this light pink here, we have the intermediate mesoderm, and that will drive or develop into the kidneys and the gonads, besides the germ cells, which are there from the beginning. The notochord will turn into invertebrate discs. So we've talked a lot about the notochord. We know at the neural tube all about that, right? We don't need to go more into that. The paraxial mesoderm, so that's in between the neural tube and the intermediate mesoderm, that will turn into the head and somites. So that's what we're going to talk about, which will then, the somite will then turn into the cartilage. So we'll get into the sclerotome and the dermomyotome and stuff, or dermatome and dermomyotome, stuff like that. So cartilage, tendons, skeletal muscle, the dorsal part of the aorta, so part of the heart, or near the heart, and then the dermis and skeletal muscle. Then we have even further out, we have the lateral plate mesoderm, and this will turn into your circulatory system, so your veins and connect to the aorta, etc. Pelvis, your limb bones, etc. So there's a lot still to develop, right? We talked about the development of the neural tube and this early development, and we got the nervous system kind of laid out, but we still have a bunch of these other systems that need to be developed here. And we're running out of time, only a few weeks left in the quarter. So we're going to hit some of these. All right, so here's just kind of a microscopy view of these developmental stages. So you can see the primitive streak here, and the migration of mesodermal and endodermal precursors. So you can see these migrating cells that will migrate through the primitive streak and back out. And then we have, I already talked about migration, formation of the notochord. So you see we have the notochord down here. Remember, it goes up, gets pulled down. The neural plate starting to develop. But you can also see, the reason I'm showing this is because we want to look further out too. So we really focused in on this little spot in the middle here, but let's kind of look further out. So we see that we're starting to get this paraxial mesoderm forming in this lateral plate mesoderm further out here. And then this is where we really see it down here in part C. You see the somite here developing next to the neural tube once the neural tube is enclosed here. And then we have this somatic mesoderm, which is behind my, you'll have it in your slides, but it's behind my image here, my face. And then the column and splachnic mesoderm and all these things out laterally. And those all develop further into other things. So, all right, so let's look at one half of a somite. So we have this lateral part, remember, it's kind of mirrored on this side over here as well. And you can see kind of through fate mapping, we've talked about that in the past, where these cells will either migrate or develop into an adult. So you see these orange cells in the middle here. These will turn into the vertebral joints, the proximal ribs, and the outer disc. And which is kind of nice here is we also have this like adult version over here. And so we have the precursor and then what it turns into. So you can see we have these vertebral joints that are derived from the internal cells here of the sclerotome. We have the dorsomedial sclerotome right up here that kind of borders the neural tube. That'll turn into your spine arch. We have the ventrolateral sclerotome, which is positioned outside. So you see most of these, there really isn't a lot of kind of migration here, more just kind of growth because they're already pretty positioned where they need to be. So although you can see that we have this is correct. So this the sclerotome here, the ventromedial sclerotome will grow around what is the notochord. So then you have the notochord here that turns into this inner disc. And you have to remember this is mirrored. So we have more of these ventromedial sclerotome cells on this side. So those kind of grow to encapsulate the notochord and then turn into the nucleus and pulpus of the inner disc. Then we have outside here, we have the ventral posterior sclerotome, which will turn into the dorsal aorta. So that does kind of, migrate towards this region over here. We have the myotome up towards the top here, which will become precursors of the skeletal muscle. And then the dermatome, which is this region up here, becomes the dermis. So lots going on here, right? So we really focused a lot on this development, but a lot of things arise from these from the sclerotome, which is just right next to it there. So derivatives of the somite, we have the dermomyotome and the sclerotome are the two regions of it. So this would be the somite, and then we have the dermomyotome, which is this top kind of thin two wide layer here. And then we have the sclerotome, which is this big kind of like triangle that goes like that, essentially. So the dermomyotome, the top part, forms skeletal muscle, which we saw along the back up there, and the back dermis, so along your back, which is forms muscles, muscle stem cells, dermis, some of your back fat cells. And then the sclerotome, like we've this is just kind of a list or a recap of what we just talked about, but it also forms the rib cartilage, which we didn't really talk about, and the tendons, the blood vessels and the meninges, the central mesenchymal region forms joints, and then some smooth muscle. So similar to what we've seen in previous experiments, there is this pre-somatic mesoderm, or PSM. Do we have that right here? That would, if we do this tissue transplant that we saw in previous, what did we see it with? Newts, or not newts, like was it a newt or frog or salamander? Tadpole or something. It was from like the second lecture of the year. I forget what the model was exactly, but I also think they did it in chicks. I think we talked about that too, with like the coat color, or the chick being yellow with black spots or whatever. Anyways, same type thing. If we take a region down towards the bottom here, a lower somite down here, and we transplant it further up towards the anterior part of the primitive streak up here, or the neural tube at this point, we will have different cells, different bone structures developing here. So ordinarily, thoracic somites, if you transplant those into a region of the younger embryo, which is caudal or anterior to the first somite, that would ordinarily give rise to cervical somites. The grafted mesoderm at that point differentiates according to its original position and forms ribs in the neck, right? So this poor chick's got big old ribs in its neck now instead of the normal cervical vertebrae. And so you can see these are already kind of destined to be the ribs at this stage of development. So the transplant of that tissue does not allow them to recommit to being cervical vertebrae. I think that's it. Yes, end of slideshow. So that's an intro to the somites. We're going to get into the next lecture. We're going to talk about somatogenesis and some things of that nature. So we'll delve a little bit deeper into it, but this is just kind of an intro. Like I said, throughout the course, I've restructured this this course to kind of, I wanted it to be a little more along the timeline of development, starting with fertilization and then cleavage and then organogenesis, etc. But because of that, sometimes everything's happening at once, right? So it's hard to to juggle everything. Anyways, that's the end of this lecture. Thanks for watching, and I'll catch you in the next one.